Hello and welcome to our lesson on adding and subtracting mixed numbers. So recall that a mixed number is a number that is mixed. It has a whole number part and a fraction part. So mixed numbers have whole number parts and fraction parts. Okay, so it's made up of a whole number and a fraction, like the 2 1/3 or the 5 3/8. So those are examples of mixed numbers. So when we have two mixed numbers to add or subtract, there are a couple of options that we can take. Actually, two if we're going to work them out by hand that I think are effective, and then one other option would be to verify work with the calculator. So that's going to be a third option, and I'll show you that one too. But if we're going to do these things by hand, one of the options is to simply add or subtract the whole number parts and add or subtract the fraction parts to come up with your mixed number answer. The other option is to convert the mixed numbers to improper fractions so that we can add or subtract. So I'm going to show you how both options work, and then you can choose. Whatever you like best is going to work fine for you. So I actually myself prefer option 2, and hopefully you'll see why before the end of this, but I want to give you the tools so that you can make the choice for yourself, okay? So let's start with example 1. We're going to try to add 2 1/3 to 5 3/8. So when we are adding these using option 1, let's add the whole number parts. So if we add the 2 and the 5, the whole number part of our answer is going to be 7. Now if we want to add the fraction parts, if I want to add 1/3 with 3/8, I have to have a common denominator to do that. So my least common denominator for 3 and for 8 is going to be 24. So I would multiply this fraction by 8 over 8, and I would multiply this fraction by 3 over 3. So now I'm looking at 8 over 24, and I'm adding 9 over 24, which gives me now 17 over 24. So I added the whole number parts to make 7. That was the easy portion of this. And then I added the fractional parts by getting common denominators, and that made the fractional part of my answer 17 24ths. So my result here is 7 and 17 24ths. And I'm going to try to make this look not so messy. And there's that. Okay? Now remember, your calculator can be used to confirm your work. And so let's see about putting this in the calculator. If I put in my fraction of 1/3 and then use my cursor to move in front of it, I can put the 2. And I want to add 3/8. So I'm going to put in my fraction of 3/8, and again use my cursor to move in front of the 3/8 to put 5, and it will tell me a decimal amount, and then it will give me the improper fraction. So what I want to know now is the answer that I have, which is 17 over 24, and move my cursor, is 7 and 17 24ths. Is that the same thing? And you can see I put both of them into the calculator, and it is confirmed that that they are equivalent, which means I did that correctly. All right, so not the easiest thing to put into the calculator. In fact, I think doing that by hand was a little faster, but maybe that's just me. All right, let's try this again. So we're going to add the whole number parts, putting together the 4 and the 3 is going to give me 7 again. Sorry for the lack of variety there. And then I got to add the fractional parts. So if I want to add 2/5 and 1/6, I need a common denominator. And my least common denominator here is 30. So I'm going to multiply by 6 over 6 here and by 5 over 5 here, which is going to give me 12 over 30 to add to 5 over 30. And now that I have a common denominator, I can add those numerators, 12 and 5, which makes 17 over 30. Really? I got another 17 in there too? Yeah, sorry. 17 over 30. So I end up with 7 and 17 over 30. That's going to be the result for this one. So let's just... how did I do this one? Way out here in space, I said 7 and 17 30ths. Now it looks ridiculous. So 7 and 17/30ths. Not that you need to write it twice. You could just box it in over there. I'm just trying to keep some fluidity in my work. All right, so those are addition problems. Subtraction will work the same way. So we're going to subtract the whole number parts. The 9 minus the 5 is going to give me a whole number part of my answer of 4. And now I have to take 3 over 7 and subtract 2 over 21. So my common denominator here is 21, which means this fraction needs to be multiplied by 3 over 3. So now I have 9 over 21, and I can subtract 2 over 21, and 9 minus 2 is going to be 7 over 21. And so I end up with 7/21 for my fractional part. So again, we end up with 4 and 7/21 here. Okay, so this maybe doesn't seem so bad to you. This isn't a terrible option. When it's not as nice is when the fractional part doesn't work out. And let me show you what I mean with like the next example. Okay, when I go to subtract my whole number parts, the 7 minus the 3 is no big deal. I get 4. But when I go to subtract my fractional parts, I have 3 over 14. And I'm trying to subtract 6 over 7. Now my common denominator is going to be 14, so I would multiply this first fraction by 2 over 2. So what I'm looking at is 3 over 14 minus, now I have 12 over 14. Well, you see the problem happening here. I can't take 12 away from 3, right? I can't take 12 14ths away from 3 14ths, which means we have to borrow. Okay, so I'm going to borrow. I had 4 whole number parts here. Okay, I had 4 wholes here. I'm going to borrow from this 4 and make it 3. And I'm going to bring the 1 whole down here. Okay, now if I bring the 1 whole down, it doesn't really help me to make it a 1. So what I want to do is think about this as an improper fraction. Now, what I brought down was a 1, and I still have the 3 14ths. If I multiply 14 times 1 and add 3, then what I'm looking at here is 14, 15, 16, 17 14ths, and I want to subtract 12 14ths, and that's going to give me 5 14ths now. So I had to borrow and bring down 1 there so that I had enough to subtract, if that makes sense. Okay, so I end up with an answer of 3 and 5 14ths here. So we can see with the subtraction how it's kind of ugly when we have to borrow. And sometimes we end up adding and we get an improper fraction, and then we have to, it's like the opposite of borrowing. We have to divide out the whole and add it to the whole number part. It just, to me, is a little more complicated than it needs to be. So what I like to do is use option 2. Now you're going to have whatever option you want available to you, but option 2 is, let's just make them both improper, and then we won't have to worry about borrowing and ending up with improper fractions. We're gonna start that way and end that way, and we're fine. Okay, so we're gonna use option 2, make these improper fractions where we multiply and add. So we have 5 times 3 plus 4 over 5, and then here's gonna be 15 times 1 plus 4. 15 times 1 plus 4 over 15. So making these both improper fractions, we have 15 and then 4 is 19. So 19 fifths, and we're trying to add 15. Did we really get? Yes. We have 19 15ths. Okay, so those are the 2 fractions I'm trying to add. I still need a common denominator, and my common denominator for 15 and 5 is going to be 15. So we're going to multiply this first fraction by 3 over 3, which is going to give me, let's see, 19 times 3 is going to be 57 over 15, and now I can add the 19 over 15. So 57 plus the 19 is going to be 50, 60, 76 over 15. And that would be my final answer for that one. And it's totally okay to have an improper fraction for the answer, or if you wanted to divide it out and make it a mixed number, 15 is going to go into 76 5 times. So let's see, 15 into 76. It goes in 5 times. That makes 75 altogether, and there's 1 left over. So 5 and 1/15 would be the mixed number. But again, I'm totally okay with the improper fraction as the answer. And in fact, the further you go into math, when you start moving into algebra and higher levels of math, the mixed numbers become kind of obsolete. Improper fractions are preferred. So again, I'm good with that type of answer, especially knowing that that's what's going to be acceptable moving forward. Okay? So there's that option. And this would have been one where we would have had to carry over anyway. Let's try it again. All right, so here, we're going to multiply. 5 times 1 is 5, and 5 plus 4 is 9. So this becomes 9/5. Plus, we're trying to add 4, which we can make a fraction by putting a 1 under it. Plus, 2 times 2 would be 4, plus 1 would be 5. So that's going to be 5/2. So that becomes that, and that becomes that. So I'm trying to add 3 fractions this time, and I need a common denominator for all of them. And the common denominator is going to be, I'm going to scooch this over, the common denominator is going to be 10. So I'm going to multiply my first fraction by 2/2. I'm going to multiply the second one here by 10/10. And then the last one here by 5/5. So what I'm looking at is 18/10. Added to 40/10, added to 25/10. And now that we have our common denominator of 10 here, we can just add our numerators. So we have 40 and 18. I started already combining some of it. 18 and 40, which makes 58. And then we want to take the 58 and add the 25. So 8 and 5 makes 13. If we carry the 1, 5, 6, 7, 8 all together there, we end up with 83. So 83/10. And that improper fraction answer is totally fine. If you wanted to make it a mixed number, let's see, if you divided 10 into 83, it goes in 8 times with 3 left over. So we could also say 8 and 3/10 for our mixed number answer. Okay, and that's easier for me, but again, if you like the other way, totally fine. All right, so let's see, I got a couple more just to make sure we're on track here. So 12 becomes 12/1. And then here, 7 times 8 is 56. 56 plus the 3 is going to be 59, so we're subtracting 59/7. So this becomes 59/7. And a common denominator for 1 and 7 is going to be 7. So let me multiply the first fraction by 7/7, which gives me 84/7. And now I can subtract the 59/7. So over 7, 84 minus 59. I'm trying to not use a calculator, so I don't know if that's a good call, but let's see, that's going to be 5 and 2/25 left, so 25/7 is going to be our final improper answer, improper fraction answer. Or if you wanted the mixed number, 7 goes into 25 3 times, that's 21, so there's 4 left over. So we could say 3 and 4/7 is our mixed number answer. And I guess it might be a good idea to check. So we have 12 here, and we're subtracting 3/7. And let's stick the 8 in front, and we end up with that, which is 25/7. And let me just make sure that the 3 and 4/7 is good. 4/7 with the whole part of 3 is the same. 25/7. Okay, so once in a while, good idea to confirm your work. I know you've seen me make mistakes before, so I like to check my work as well. We're all human. All right, last one. So if I multiply here, 9 times 6 makes 54. 54 plus 7 is going to be 61/9. And then 18 times 2 is 36. 36 plus 5 is going to be 41, so we're subtracting 41 over 18. Common denominator for 9 and 18 is 18. So we're going to multiply this first fraction by 2 over 2. That's going to give me 122 over 18. And now I can subtract the 41 over 18. So we get over 18, how much? 122 minus 41. That's going to be 81. So 81/18 is going to be our improper fraction answer. And if we wanted to make that a mixed number, we could say, let's see, how many times does 18 go into 81? 5 would be too much, so let's say 4. That's 2. The 4 times 8 is 32, so if I carry the 3, 4 times 1 plus 3 is going to be 7, so 72. And there would be 8, 9 left over there. So we could also say this is 4 and 9/18, but technically 9/18 reduces. 9 goes in there once and in there twice. So we're going to say 4 and 1/2 would be the best answer if it was in mixed number format. Now again, let's just verify. Delete all this out. So 7/9, put in my coefficient, my whole number part of 6, and we're going to subtract 5/18, and let's make a whole number part of 2, and then we end up with 4.5, which is, oh, 9/2. Yeah, geez, 9/2. I didn't see it right here. 9/2 is what we have, but this is a fraction that's not in its simplest form. So it's a good thing we're checking our work. Let me just back this all up here. So 18, I don't know why I didn't see it here. When we have 81 over 18, there's a common factor. Not sure why I didn't see it, just didn't. But these are both divisible by 9, so we should reduce. Let's reduce by dividing both the top and the bottom by 9. And that's going to give us 81 divided by 9 is 9 in the numerator, 18 divided by 9 is 2 in our denominator, so there's our 9/2. And then when we make it a mixed number, we won't have to worry about reducing. If 2 goes into 9, it's going to be 4 times evenly, that's 8, and there's going to be 1 out of 2 left over, so there's our 4 and 1/2, and that makes that look a little nicer. So there's 9/2, and again, if we wanted to check the 4.5 is 4.5, it's going to be the same thing we have there. So all confirmed. Calculators are super helpful. All right, so you have a calculator to verify your work. You have the option of making mixed numbers and then adding or subtracting. And you have the option of adding and subtracting whole number parts and adding and subtracting fraction parts. So it's kind of whatever's going to work for you. Hopefully you've got enough to get going on your practice, but as always, if you need some additional help, then just reach out. All right, guys, take care.